Hello everyone, welcome to my lecture. The purpose of SQL injection. SQL injection attacks are used by hackers to achieve certain results. Some SQL exploits will produce valuable user data stored in the database, and some are just precursors to other attacks. The following are the most common purpose of a SQL injection attack. Identifying SQL injection vulnerability. The purpose is to prove a web application to discover which parameter and user input fields are vulnerable to SQL injection. Performing database fingerprinting. The purpose is to discover the type and version of database that a web application is using and fingerprint the database. Knowing the type and versions of the database used by a web application allow an attacker to craft database specific attacks. Determining database schema. To correctly extract data from a database, the attacker often needs to know database schema information such as table names, column names, and column data types. This information can be used in a follow-on attack. Extracting data. These types of attacks employ techniques that will extract data values from the database depending on the type of web application. This information could be sensitive and highly desirable to the attacker. Adding or modifying data. The purpose is to add or change information in a database. Performing denial of services. These attacks are performed to shut down access to a web application, thus denying service to other users. Attacks involving locking or dropping database tables also fall under this category. Evading detection. This category refers to certain attack techniques that are employed to avoid auditing and detection. Bypassing authentication. The purpose is to allow the attacker to bypass database and application authentication mechanisms. Bypassing such mechanisms could allow the attacker to assume the rights and privileges associated with another application user. Executing remote commands. These types of attacks attempts to execute arbitrary commands on the database. These commands can be stored procedures or functions available to database users. Performing privilege escalation. These attacks take advantage of implementation errors or logical flaws in the database in order to escalate the privileges of the attacker. SQL injection using dynamic strings. Most SQL applications do a specific predictable job. Many functions of a SQL database receive static user input where the only variable is the user input fields. Such statements do not change from execution to execution. They are commonly called static SQL statements. However, some programs must build and process a variety of SQL statements at runtime. In many cases, the full text of the statement is unknown until application execution. Such statements can and probably will change from execution to execution, so they are called dynamic SQL statements. Dynamic SQL is an enhanced form of SQL that, unlike standard SQL, facilitates the automatic generation and execution of program statements. Dynamic SQL is a term used to mean SQL code that is generated by the web application before it is executed. Dynamic SQL is a flexible and powerful tool for creating SQL strings. It can be helpful when you find it necessary to write code that can adjust to varying databases, conditions, or servers. Dynamic SQL also make it easier to automate tasks that are repeated many times in a web application. A hacker can attack a web-based authentication form using SQL injection through the use of dynamic strings. For example, the underlying code for a web authentication form on a web server may look like. A hacker can exploit the SQL injection vulnerability by entering a login and password in the web form. The SQL application would build a command string from this input. This is an example of SQL injection. This query will return all rows from the user's database, regardless of whether Kimberly is a real username in the database or Grabs is a legitimate password. This is due to the OR statement appended to the where clause. The comparison is equal to will always return a true results, making the overall where clause evaluated true for or all rows in the table. This will enable the hacker to log in with any username and password. SQL injection countermeasures. The cause of SQL injection vulnerabilities is relatively simple and well understood. Insufficient validation of user input. To address this problem, defensive coding practice such as encoding user input and validation can be used when programming applications. It is a laborious and time consuming process to check all applications for SQL injection vulnerabilities. When the implementing SQL injection countermeasures, review source code for the following programming weaknesses. Single quotes, lack of input validation. The first countermeasures for preventing a SQL injection attack are minimizing the privileges of a user connection to the database and enforcing strong password for SA and administrator accounts. You should also disable verbose or explanatory error messages so no more information than necessary is sent to the hacker. Such information could help them determine whether the SQL server is vulnerable. Remember that one of the purposes of SQL injection is to gain additional information as to which parameters are susceptible to attack. Buffer overflows. As a CEH, you must be able to identify different types of buffer overflows. You should also know how to detect a buffer overflow vulnerability and understand the steps a hacker may use to perform a stack-based overflow attack. Types of buffer overflows and methods of detection. Buffer overflows are exploits that hackers use against an operating system or application, like SQL injection attacks. They are usually targeted at user input fields. A buffer overflow exploit causes a system to fail by overloading memory or executing a command shell or arbitrary code on the target system. A buffer overflow vulnerability is caused by a lack of bonds checking or a lack of input validation sanitization in a variable field, such as on a web form. If the application doesn't check or validate the size or format of a variable before sending it to be stored in memory, an overflow vulnerability exists. The two types of buffer overflows are stack based and heap based. The stack and the heap are storage location for user supplied variables within a running program. Variables are stored in the stack or heap until the program needs them. Stacks are static locations of memory address space, whereas heaps are dynamic memory address space that occur while a program is running. A call stack or stack is used to keep track of where in the programming code the execution pointer should return after each portion of the code is executed. A stack based buffer overflow attack occurs when the memory assigned to each execution routine is overflowed. As a consequence of both types of buffer overflows, a program can open a shell or command prompt or stop the execution of a program.